Hello, my name is Gerhard Adam, and in this module we will take a look at generation data sets, how to create them, how to use them within the JCL requirements that we have for data set naming. In particular, with generation data sets, we are interested in how they can be applied to the data sets that we are going to be using. In the first place, let's consider, for example, the standards that are associated with data set names in the first place. A data set name has this basic format with various levels, and in this particular case we can have up to 8 characters per level separated by dots with a maximum length of 44 bytes, as we discussed previously. Each level is called a qualifier, and from those qualifiers then we have A's, in this case representing the high level qualifier, and the E's representing the low level qualifier. The intermediate ones we normally don't worry about, we don't classify them as anything, because the high level qualifier is normally used to establish things like security access as well as association with a particular catalog, which we will discuss shortly. The low level qualifier has limited value, but sometimes it is used within certain contexts to identify the type of data set that we're dealing with, and it will certainly play a role in generation data sets. The naming standards themselves for data sets are going to be installation established. As we'd indicated, very often you have security related issues, and you also have storage administration policies and other factors that can influence the names that are required. So the installation will normally have a naming standard that is going to be used for data sets, whether they be test or production. The high-level qualifier, as we said, is generally going to be controlled by security, and in most cases, the test data sets, in order to be able to have unconstrained access, will be your TSO user ID, since you have security access to everything that you control under that particular ID. The catalogs themselves are another aspect, though, that we need to explore a little bit, because generation data sets are controlled by the catalog themselves. Now, the catalogs involve the data sets that are used by the system to keep track of where various data sets and files are. So there is a master catalog, which is used by the system during initialization, and then there can be a whole range of user catalogs that are used to define various subsets, whether they be production, whether they be TSO users, or whatever data set naming standards exist. You can have as many user catalogs as you like in order to be able to contain these definitions. So the master catalog is reserved typically for system-related data sets, and then it contains alias pointers to the various user catalogs. And these aliases are based on the high-level qualifier of the data set. So for example, your TSO user ID would have an alias assigned to it, and that would connect it to a particular user catalog. So any data set name that began with your TSO user ID would then be defined within that user catalog. The catalog information then is going to be driven by the high-level qualifier, and the information that is going to be recorded there consists of the device type and the volume serial number of where the data set is located. So this becomes a lookup point. So when we refer to a data set name in our JCL, the system checks the catalog, locates the name, identifies the device type and the volume serial number on which the data set resides, and assigns it to our job. That's the role of allocation when we specify these in our JCL. Here's an example of a catalog entry for standard data sets. They are classified as non-VSAM data sets, and you can see in this case here, it indicates the name of the data set, it indicates which catalog it is recorded in this case usercat.user01. We have the volume serial number, and then we have a device type. Now the device type looks cryptic because it's a hexadecimal value, but in fact this particular designation here indicates a 3390 disk drive. So this is what the system is going to use now when it looks up these particular data sets. The generation data group is a definition then that will be placed in that catalog, and it establishes a base data set name that is going to be used for the generations that we create. The system then generates a unique number in the lower level qualifier for that data set that allows us then to create unique entries. So in other words, if we have a data set called userid.dataset, then the system will add this generation number to create a unique name. And this number then will be incremented every time a new generation is created. Specific generations then can be referenced using a relative number. And this way we don't have to explicitly specify the generation number that the system has generated, but instead, because of the fact that the information is kept in the catalog, we can refer to them by a relative number. And the relative number indicates that 0, +1, -1, these are going to be the kinds of references that allow us to determine what generation we are referring to. In addition, we can define the generation data group to consist of a certain number of data sets that are going to be retained. And so when we create generations that exceed that limit, then the older generations are automatically deleted. In particular, here's an example of how we can define a generation data group. We are using an IDCAMS vsam utility command in order to define this entry into the catalog. The specifics of this will be covered in the last module in this section, but basically the idea is we define the generation data group, assign a base name to it, establish a limit as to the number of generations we want to retain, and then indicate whether or not we want them automatically deleted, whether we want the entire pool of generations to be emptied. Those are the values that we get to specify here. And so in this case we have a limit of 5 generations. We will automatically delete the oldest one when the limit is exceeded, and we will remove only the oldest data set when the limit is exceeded rather than removing them all. And that's what these options signify.